Good morning, afternoon, evening, everyone, wherever you've joined us from around the world. I'm Thomas Neeson, I'm Managing Partner at Cundall, and I'm very pleased to welcome you all to our second session of our webinar series on sustainability. This one's entitled Material Selection and Design. We'll cover a whole range of topics over these 6 weeks, and then we're going to carry on with more webinars following that, as we're going to focus on the target towards net zero carbon. So please look out for those and join up when you see them advertised. We obviously meet in really challenging times, but when we get through the current coronavirus crisis, we'll return to focusing on how we build our environments for the future and how we minimize our impacts. If there's some good that'll come out of this crisis, I think we're beginning to realize how much we consume, and we're beginning to see that if we stop the level of consumption in terms of that be materials, material goods, the amount of travel that we do, etc., we really can have a positive impact on the planet we all live on together. Now, sustainability is at the heart of everything we do in Cundall, and today's webinar is just one part of our work to achieve what we've published in our sustainability roadmap and delivering on what we call our cornerstones, which is the impact we have on our homes and communities, the places we work, on all of the projects we get involved in, and in providing industry leadership to drive us to a better place of how we carry out our work. Today's seminar is about 20 minutes long, I think. So we will, and Lee will try and pack in a lot of information and download a lot to you in that period. Then we'll have a Q&A session at the end of it. Lee loves questions, so please be keen and please get them thought about on the way through, and we can ask them using the Q&A box on the side of the screen. We're also here to learn. We're trying to give you some information, but if you can teach us anything, we're more than willing to have that, and we welcome it. So give us your thoughts and questions on the way through. And if we don't get through all the queries, we'll respond by email following the webinar. So today's speaker, Leston Jones, is a partner, sometimes in our Manchester office, now based in our Peak District office. He's a structural engineer with 25 years experience, and he has a very strong interest in the role of engineers in sustainability and likes to lead on this and how we impact through resource consumption, which is really the basis of this talk. He's presented on this talk throughout the UK and internationally across the globe. I know he's done it in Hong Kong and in other locations. And today Lee will provide an overview of where things are moving, how we can make better design decisions to reduce the impact of the materials that we all consume. Lee's also active in industry in the Institute of Structural Engineers, sits on their Futures Committee, which overlooks Sustainability Committee. So without further delay, I'll hand you over to Lee. Enjoy the webinar, and we look forward to your questions at the end. Thank you.
Right, we've got you back.
Are we back?
Yeah, we're back.
Back, and you can hear me.
We can hear you. Thank you.
Good. Okay, well, I'll jump through some of these things. I'm not sure if you heard any of that at all, but yeah, Cundall's...
None of it.
Okay, so Cundall's dates back to 1976, multidisciplinary consultant, and we have, over that time, a long commitment to sustainability. So we were the first consultant registered under One Planet Living, and we've got targets set ourselves to move towards net zero carbon by 2020, which, as Thomas says, will be subject of some future discussions. And we've moved very fluidly in towards the agile working, so our global offices have gone up from 21 to 950 fairly seamlessly over the past few weeks. You can see on the map our locations around the world, so strong focus across Europe, moving into the Middle East, Asia, and down through Australia. But we've worked extensively across 50 countries or so presently around the world. And our services, our core services are civil engineering, structural engineering, building services, and sustainability. But then as we've grown and the projects and clients have required further expertise to support those, we've expanded that with a series of specialisms from acoustics, air quality, health and well-being, lighting design, etc. And a lot of these cross over as well very much with our sustainable foundation. So moving into the main presentation, looking at what the impact is. So I think it's just first to understand really how much materials do we consume and what's the environmental and ecological impact of those as we go forwards. So I think it's long been known that the built environment is significant in terms of greenhouse gas emissions. And we consume something, or we emit something like 35%, a third of all greenhouse gas on a global scale. But I think for a long time, the focus of that has been on the operational carbon. And not really a great amount of consideration of the materials, but that's starting to change. It's changed significantly over the past 2 years and is gaining pace all the time. And if you look at it, it's easy to understand why. We consume as an industry something like 40% of the world's materials, and that creates great environmental impact, great destruction as we extract the materials to build new cities and towns. We consume something like 50% of the global steel, and it's increasing all the time. So that's gone up 40% in the past 10 years. And concrete's the most abundant man-made material on the planet and currently makes up over half the mass of all materials that exist today. And quite phenomenal usage. But we're not very efficient with the things we use either. So when we get to construction stage on a project, something like 10% to 15% of the materials that arrive at site never actually are utilised in the buildings and end up being a waste product of the construction process. And something like 91% of the buildings are demolished before the end of the serviceable life. So those buildings still function perfectly well, but they're probably considered not fit for use. So the easy option often is to demolish those and to rebuild things. So how does that sit in the context of the carbon budgets that we're working towards? So back in 2008 that we set a target, or we committed to a target to reduce our emissions from the UK perspective, similar moves across the world, by at least 80% by 2050 compared to the 1990 levels. And you can see on the graph on the right hand side that there's been big moves as we've moved forward from there in terms of the budgets. And these are the 5-year carbon budget blocks that you've got going forwards and the projected reductions. So it's been something like a 40% reduction over the period that's been monitored, and that's largely been achieved through decarbonisation of the grid. But the Committee for Climate Change meetings in 2016, they identified that that's only going to get us so far, and we need to start to think about other strategies to deal with material consumption, agriculture, and various other things. And it's picked up as that one of the key actions to take is to review the emissions from productions of steel, concrete, plastic, and aluminium, which are the key constituents of the built environment. But that material consumption is set against an increasing demand. So we've got clear population growth going forward as we move towards the end of the century. That's due to increase from around 7.8 billion to about 11.2. So that's the equivalent of building a city the scale of London every 38 days. So it's pretty significant. And what we're also seeing as well is you can see the proportions of the less developed regions and the more developed regions on the right. And as we move forward, the less developed regions are demanding, quite rightly, a greater share of their share of the world's resources. So they are actually developing at a greater rate. And again, that's putting a drain on materials. And there was a study done by Material Economics, which then took that sort of growth data and established what that means in terms of individual materials. So if you look purely at steel, aluminium, and cement, they account for something like 85% of the carbon footprint of buildings. And they're set to increase by 2.3, 3.4, 1.7 over that time. So you've kind of got a twofold increase in the material consumption as you go forwards. And when you consider that cement on its own is responsible currently for 7% of global CO2 emissions, that's going to be challenging for us. And that's presently tripled in the past 10 years. So it's really time for change if we're going to get anywhere near meeting our carbon commitments. So what can we do about that? How can we drive this forwards? Well, we did a materiality review, as Thomas mentioned, back in 2018, where we looked at our role as consultants across those 4 cornerstones and how we can try and drive improvements. So there's a very strong focus on our projects because that's the largest area of influence in terms of environmental responsibility. And we maintained the elements very strongly that we'd focused on historically with zero carbon, health and well-being, but we also brought a far greater emphasis into the materials aspects through there. So climate positive action, which is looking at whole life carbon through there, and material consumption and waste, where we're looking at reducing material usage and using that more responsibly. So if you look at a model to try and drive that forward, I think that the Ellen MacArthur diagram has been quite well established. And you've got two cycles there. You've got the biological cycle on the left-hand side and the technical cycle on the right-hand side. And the ethos really is trying to keep your loops as tight as you can to keep your materials at the highest value, and then recycling them back into the material chain. So as you move out from there, you've got maintenance, reuse, refurbishment, and recycle. I think it's been well established and well adopted in terms of components, if you like. So there's been big moves in terms of carpet tiles, lighting, mobile phones, cars, all those sorts of things, but it gets quite hard to apply that to a whole scale building. So we try to think about how we can break that down. And that's led us to look at this in terms of 4 steps. And this is just a quick overview, but we'll go through each of those 4 steps in turn. So you've got lean design, where you look at looking at how you can reduce the amount of material you utilize. Low impact design, where you then try and prioritize materials that reduce resource consumption and have low embodied impact. Lifelong design, so looking at loose designs that can adapt and evolve, so make sure that we're trying to demolish less buildings and extend the use of those buildings. And then ultimately looking at responsible specification and procurement to make sure those decisions are carried through to the built form and that we maintain social and environmental transparency through that process. So focusing on lean design, I think the first one is looking at, can you reduce the requirements for new builds? As I say, we've kind of all moved to an agile working practice over the past few weeks, but even taking that back into our normal day-to-day lives, if taking offices, they're probably occupied something like 50% based on a lot of research. So if you look at agile working practices, you can maybe get a 20 to 40% saving in terms of floor space requirements by moving more towards agile practices. So I think looking at our business models can be one of the first things. So if we can build less, obviously we use less materials. So that's kind of the top of the hierarchy. Then it's looking at what existing assets we have. Can existing buildings be repurposed rather than demolished? And looking at the built form of those buildings when we move to new builds. So what column grids, what height of buildings start to become optimum in terms of floor efficiency, but also carbon efficiency. And then as we move through there, we can look at advanced analysis tools that further optimize that built form, and then look at how we can minimize waste as we go forward. So just a couple more points on those. So I say it's great to repurpose existing buildings, and I think often this doesn't happen because multifold reasons really. Often it's quite a hard decision. Often we don't know that much about the existing buildings, so there's quite a lot of work in finding that, and that brings intrinsic risks to projects. But as we go forward and the embodied carbon is seen as a resource, I think that's something we need to prioritize a lot more. It's important when we look at that we look at the balance of both embodied and operational, so we are making a whole life carbon decision. But there's a lot that we can do to achieve that, and we need to consider other aspects like the heritage value, the residual life of the existing structures, and how flexible it is for its new uses. And obviously cost is a primary driver in everything that we do. So I think when we refurbish, we need to be retaining as much as we can to protect that embodied carbon asset. But I think we also shouldn't be scared of quite deep interventions and retrofits of buildings to deliver that and still preserve some of the materials. I say on built form, again, taking offices as an example, we've moved more and more to increasing column-free spaces. And whilst this is good from a flexibility in terms of layout, it does come at quite a high embodied carbon price. So again, I think it's just important to consider, is that the optimum solution if actually we were to break those grids down to 9 meters rather than 15 plus meters? How much does that impact on the use of those spaces? And looking at those utilization ratios and what's the best balance overall. And similarly, as you start to build higher and higher, your efficiencies go down significantly, and that comes at a carbon price. It's then looking at how efficient you actually then design those buildings once you've developed a form. So there's a study undertaken by University of Cambridge which states that carbon emissions could be reduced by something as much as 50% by looking at optimizing the design standards. The design standards and design approaches. And we've looked at that, and we've done some further research with Edinburgh University, and we don't quite see that there's 50%, but we do find that there is a saving that can be reduced, taking historic data. And a lot of this stemmed out of work in the 70s, where engineers were taught really to standardize things as much as we can, because that's the most economic and the easiest to manufacture. But we've moved to times where we've got quite advanced design and manufacture tools which can interface very, very smoothly. So we're now using extensive parametric modeling on our projects, which really let us optimize our built form solutions and bring those material consumptions and hence the embodied carbon down as we go through there. And the other area we're pushing on is looking at how we can minimize waste. So I say construction waste is significant. We've been utilizing BIM on all our projects for an extensive time, and that brings down clashes that could occur on site by building it virtually initially. And that delivers savings on waste. Also, off-site manufacture has been a big move, and whether that's volumetric, panel or component scale, there's big benefits in terms of working through there. That links into the next one in terms of looking at component size. And I think when you get to design for manufacture, they're very good at optimizing the use of component sizes, so you don't get small offcuts on panels, or you need a panel and a little bit and all that sort of thing. So you're working with the size of the elements that are naturally manufactured. And they're also doing some research presently on 3D printing and where that may take us, but potentially delivers great savings on material quantities. Just a quick project example here, Here East was a temporary venue for the London Olympics back in 2012. And at the end of the event, it kind of became a redundant space. So we went in there and did quite a deep cut and carve through there, introduced several new floors, looked at overloading some of the existing foundations and extensive facade and internal reconfiguration. So it's just an example of how you can really regenerate an existing building and bring it back to life, and not just focusing on the heritage buildings, which tend to be the things that are repurposed. So low impact, really starting to focus on the impact of those materials, embodied impact particularly. So looking at embodied carbon and carrying out embodied carbon assessments early in the design process. So really at your very, very conceptual stage, looking at the impact of different solutions, looking at that through the whole life cycle, so from manufacture to end of life, and then embedding this in your workflow so it doesn't become a bolt-on, it just becomes part of your day-to-day practice. So we've linked that through to BIM. And then from there, you can prioritize recycled materials with low impact solutions, and looking at materials with appropriate design life so that you don't need to necessarily replace those. You've got the inbuilt durability, so they'll last the life of the building. And then capturing those decisions into our specifications. I think historically there was very little driver on this. There was a lot of driver on operational, but we're seeing that change. RICS, RIBA, UKGBC have now produced quite extensive guidance on that. BREEAM has got a far greater emphasis on embodied carbon as we go forwards, and the London plan and other plans around the world are starting to bring this into focus as well. So again, they're calling for a whole life cycle, which is not only operational, but it's embodied as well. And what is embodied carbon? I think it's becoming increasingly known, but just in summary, it's really taking those materials and looking at the energy consumption as they go all the way through. So going from the material extraction, whether that's digging materials out of the ground, taking that into your manufacturing process, and then cement works, etc., and all those things, and taking it through to the warehouses. So that's kind of your cradle to gate stage. Then you go through to your site stage where you've got transportation to site, and the emissions that are then involved in the construction of the building, so your cranes, your machinery and everything else. You then get into an operational stage, and many materials require some maintenance, some require replacement, so that sits within there. And then again, you've got an impact from the demolition stage and the processes of that. And then you get to end of life, and you look at how those materials then could either be reused, landfilled, recycled, and what the carbon impact of that, whether that's a positive or a negative. And there's now a good standard, so BSEN 15978 has now defined that. So you've got the product stage going all the way through to beyond life cycle stage, and they're referenced A1 through to D. And you can see the elements in blue on the diagram are those really which relate to your embodied carbon assessment. So it's quite extensive that we consider those, but all of those have a significant impact on the decision as we go forwards. And I guess just to summarize why there's such a big driver on this presently. So if you look at operational carbon, as I say, that's gone down significantly through decarbonising the grid, and we're moving towards a transition away from fossil fuels. So as we move over time, the circle, the overall scale of impact is reducing, but the grey is historically the operational and the green is the embodied. And this is different ratios for different typologies of buildings. But what you can see is the circle's getting smaller, so we're doing the right things by reducing the operational, but the impact of the embodied is getting proportionally larger, so it kind of brings it back up on the agenda. And actually, there's a few key drivers on this. So if you look at the study by British Land back in 2011, they looked at Leadenhall building, and there's been various other studies, and they tend to say that 50 to 85% is directly attributable to the structure, which is hence my big interest and drive on this. And again, that changes. You're probably more like 50 on an office building and moving towards 85 as you go more towards industrial buildings. So significant areas for impact on just a few material decisions. The other thing that makes this more viable nowadays is we've actually moved towards a good process of understanding the carbon footprint of our materials. So historically, there's very wide-ranging opinions, but there's been standards again, international standards, which unify that. And we're starting to get environmental product declarations for many materials, which give a carbon footprint across each of the life cycle stages we talked about before. Circular Ecology also have produced the ICE database with the University of Bath, which is good at the design stage, because rather than focusing on one manufacturer, it looks at a typology of material and then does a standard distribution assessment. So it gives market standards, if you like, in terms of what is a likely carbon footprint for those materials at the design stage before you know who your manufacturer is. So what materials can we do? I mean, in an idealistic world, maybe we'd move towards buildings such as straw bales and rammed earth and build everything out of those. And they're great materials. They produce really nice internal environments. Things like rammed earth provide natural cooling, but they're not applicable to every building we're delivering. So we need to think about what we can do with the existing materials. And there's a lot we can do. So if you look at steelwork, that's one of the key ones. Steel's manufactured in two different ways, electric arc furnace and blast arc furnace. And they're able to take different constituents of recycled content. So your blast arc furnace traditional can take up to 20% recycled steel, and that comes out with a carbon footprint of 2.5 kgs. But as you move towards electric arc, you can get up to 80% recycled, and that brings it down to 0.97. So you can make very quick decisions, very big impacts through those sorts of specification decisions. And similarly on concrete, there's a lot we can do. So the blue diagram showed different types of concrete mix. So as we put in cement replacement in there, which is a byproduct of other manufacturing. So it's an upside because it's a waste product to start with, but then also as you put more and more in there, so as you go towards 50%, you can get something like a 40% reduction in the carbon footprint of the concrete. And that concrete's not reduced in strength or durability, it's just as good. Because you're using waste products, it tends to not come at a cost premium, but it does have some program impacts because the strengthening rate is slowed down. And that's something you need to consider, and you need to think about the blend of how much cement replacement you can utilize whilst not negatively impacting the program, and that'd be different for different components. And timber, so is timber the holy grail? Well, timber's great because as it goes through the extraction stage or the growth stage, it's capturing, sequestering carbon into it. So actually it comes out at the cradle to gate stage with a negative carbon impact. So it's stored lots of carbon in there, and that's great. But what you have to remember is what you do with that timber at the end of life. So that's why I'm saying it's important to consider the whole stage. So if you just take that timber and put it in a field and let it degrade, then it will release all that captured carbon back into the environment. So it's important not to forget that. If you can reuse it, then obviously that's great. And if you do things like waste to energy, then you get a benefit from there. But we need to think about, again, if you're trying to move towards a zero carbon community, then that's quite a hard thing to balance. So from our perspective, as I say, we're plugging this into BIM. Typically we use the ICE database, although we've developed that for a few materials we find we're typically specifying. And as the diagram on the right can say, which shows from University of Wolverhampton, at early stages we can generate BIM models, put in the relevant materials, and it very quickly shows a carbon comparison of those, which informs our early design decisions. And then we can track the detailed design as we go forward against those and we're starting to try and establish benchmarks for performance of buildings. We've also been doing work in Hong Kong. We've developed a carbon assessment tool for Construction Industry Council. So this is being adopted across all projects in the region and starts to look at, from the design stage, a carbon assessment of the shell and core and envelope of buildings, and then tracks that as it goes through the construction stage to monitor performance against the design to make sure that's maintained. And it's also developing a benchmark in terms of where those buildings should then sit to inform the industry as we go forwards. A little example, in our Birmingham office here, we used timber panels to form quite a beautiful feature staircase in the centre of the office. So a great material because there's sequestered carbon in there, but we also worked hard to make sure it was all sat within standard panel sizes and to reduce waste and everything as we go through there. So quickly moving into lifelong design. So just thinking about how the buildings we move can adapt and evolve to suit different needs, whether they're short-term through tenant changes or longer-term through change of material, change of use. I think we also need to think about climate resilience, but that's quite a long debate, so I think we'll save that one for a future webinar. And then looking at how buildings could be dismantled and repurposed at the end of life, and thinking of things like creating an asset log so that we can asset tag materials, we can capture that in our BIM models. One of the things that stops reuse of materials or adaptation of buildings is because often we don't know much of materials. So if we can capture that at the design stage, that will protect the future of our buildings. So adaptability, I think it's some of the small things. It's thinking about how much services flexibility we need to put in there in terms of horizontal, vertical distribution. As we get climate change, we'll get heating environments, and that will put on potential demand for greater air movements through buildings and things like that, and cooling. And also things like vertical connectivity, looking at knockout panels for stairs, which again may make the building more useful. We need to balance that against the materials that go in to put that flexibility there, but some early consideration of those. And then also consideration of change of use. So making sure decisions we do don't block to a great extent the potential to change. So things like moving from offices to resi has been quite prevalent over recent years. And whilst it's not possible to build for every scenario, thinking about any decisions that impact the flexibility of that space that maybe you could design for a different way. And design for this deconstruction, I think this is kind of the holy grail of circular economy, that all our buildings we can then unbolt or dismantle through the constituent parts and then take away and use in different places. But our buildings all tend to be, have large portions of quite unique elements in there. And I think also the market supply gets quite complex because you're then designing for a building and it's hard to understand where your materials are going to come from unless you've already ordered those and procured those from an existing asset. So it gets quite difficult, and the cost premium isn't there. So the cost difference between recycled steel or steel reused from a building is about £300 per tonne less than just buying raw steel. And when you look at the complexity of the supply chain and the procurement on that, other than in some unique buildings, that tends to block the use of that. So I think there's a way to go on this, but I think we do need to think how we can best dismantle buildings that we have. And this is Notre Dame College that we did in Liverpool. We really tried to embrace the ethos. So essentially it's a 80 by 50 metre, 12 metre high, large shed. And then the education building is put in there, but ultimately everything could remove out from there to completely change what that building is. And the education spaces are in a loop around the perimeter. And so they can still be pulled out, but they get good natural light, good natural ventilation from the perimeter of the building. And then you get fully adaptable and agile spaces which sit in the middle, which again lets change of the use on a regular basis to happen. So quickly finishing on specification and procurement, I think it's just important to consider how we then capture all this in our specifications and getting it into specifications as early as we can. We shouldn't underestimate the value of the supply chain in this, and they can bring an awful lot to this decision process with innovation and best value. So engage them, get those discussions going early as we can. And then embed the requirements for responsible sourcing and certification in there, so we know where the materials are coming from, the chain of custody of those, and focusing on things like deforestation and that through that. And then looking at transparency and responsibility throughout the supply chain. And I think that we often think about, or we forget about the slavery industry in the construction industry, but it is still very prevalent. And as you move to certain parts of the world, increasingly so. So we need to think about how we cascade that with the materials we are specifying that they're responsibly sourced. So a very quick whistle-stop tour through quite a lot of content there. So hopefully that was useful, and we've got more coming in the series. So Gordon Reed, one of our structural partners, is presenting next Wednesday on offsite construction, which crosses over quite a lot with the carbon debate, but looking at how that's, what the future of that is in the built environment. And then over coming weeks, we've got a talk on co-working, the evolution of the workspace, overheating in residential, and then the impact of office lighting on health and well-being. So hopefully be able to join some of those. So have we got any questions there, Thomas? Is Thomas a question master?
Natalie's the question master.
Wouldn't trust me with being question master.
Just one in, and obviously we're quite tight on time, so we'll just do that one quickly. So from Olga, as we decarbonise the grid, will the issues of embodied carbon not reduce in parallel?
It will to some extent. So I think it's important when you put in carbon databases into your models and your decision making, that you update those on a regular basis, because some manufacturing processes will decarbonize and that will drive it down. But there's other things there. So if you look at the extraction of materials, it's quite hard to decarbonize that presently, and transportation, because they're generally fossil-based fuels. So there's a way to go on those before they're fully electric, although there are moves that way. But taking cement, there's a chemical reaction that occurs as well. So a large part of the emissions of cement are directly linked with the chemical process.
Thank you very much. There's just another quick one that's come in there, asking if there's going to be a recording of this webinar. Yes, there will be, and we'll be sending it out so that you can access this at a later time as well. We are also running 2 of the same, so Lee will be doing another webinar at 9:30, which is UK time as well, and that's going to be the same for all of the webinars over the next few weeks. But we'll get all of them on our YouTube, and we'll share the link with everyone who's signed up. So brilliant, I think that's everything. So thank you very much for your time, Lee. Thank you, Thomas. And we hope to see you again in some of our future webinars.
Yeah,
super. Thank you all for joining us.
The following ones, yeah. Thank you all.
Thank you. Goodbye.
Bye.
Thank you.